The population is a set of objects, and the sample is a subset of that population. For example, let's say you want to find out how large part of a population that likes coffee. Of course, you could ask everyone in the population, but if the population is all the inhabitants of a country, then that's not very practical. So instead you take a sample. So for example, let's say that you randomly choose 1,000 people and ask those. And let's say that 89% of those like coffee. Then the natural estimate is to say that 89% of the population also likes coffee, based on this sample. Another important concept in statistics is a random variable. It can also be called a stochastic variable. A random variable is a variable, but every time you observe the variable, it takes on different values. And the different values are taken on by different probabilities. For example, if you throw a die, and now let's say it's not a normal die, but some distorted die, and it doesn't have to be six-sided, and the faces doesn't need to have 1, 2, but it could have any number. For example, like this. Then every time you throw the die, you will get a certain outcome with a certain probability. And that constitutes a random variable. So if you have a number of outcomes, let's call them U1, U2, up to UM. So you have M outcomes. And if you assign to these outcomes a value, for example like this, and each outcome occurs with a certain probability, then this constitutes a random variable. And random variables denoted by capital letters, for example X, Y, or A, B. So if you observe a random variable, every time you observe it, it will give you different values with different probabilities for the different values. For example, one random variable could be the outcome on a six-sided die. Or for example, the weight of a luggage at the check-in at an airport. So if you stand at the check-in and watch people check in luggage, then you take a random person, what is the luggage weight they check in. That could be a stochastic variable. Or for example, the temperature of a cup of coffee a random person orders at a cafe. For example, the first person maybe gets a cup of coffee with 87 degrees Celsius, and the next one 91 degrees Celsius. The third person 85 degrees Celsius, and the fourth person again gets with 87 degrees. Then each temperature occurs with some probability. For example, it's much more unlikely to get a cup of coffee with 20 degrees than to get it with 90 degrees. A discrete random variable is if it has outcomes that are discrete numbers on the number line. For example, 1, 2, 3, or 6, 18, or 24. So there are not values in between. A continuous random variable, you can get any outcome in an interval. For example, you can get any value between 1 and 2. Example of the first one could, for example, be if you buy apples at the store. Then you can get 1 or 2 apples and 3 apples, but you don't buy 1.5 apple. And continuous random variable could, for example, be if you measure the height of a person. Then he could have any height between 0 and 3 meters, for example. But the last example could also be an example of discrete, if you limit yourself to integer centimeters, for example. So it depends on the context.